Good morning. I work for SILR, which is a joint institute between University of Michigan and NOAA Great Lakes Research Lab. And what I'm going to talk about is based on the results on the fairly large project which is just finished. And the project dealt with the prediction of spread of invasive species in the Great Lakes region. So some of the colleagues on the project are listed here. And I think in the abstract or whatever form I filled before, there's a reference to this synthesis paper based on the results of this project led by David Lodge. And the particular topic I'm going to talk about is covered in the paper that was just accepted by the Journal of Great Lakes Research, which I have a reference later. And the project was funded by the NOAA, Sea Corps, and also EPA GLRI, Great Lakes Research Initiative. So I'm a physical oceanographer by background, so all these guys who were listed on the first slide are biologists, so they kind of advised me what to do. So, but my interest was for a long time is the circulation patterns in the Great Lakes. And there are quite a few species which invaded or potential invaders, which have pretty long pelagic phase. And obviously, when you have a long pelagic phase, you may think that currents circulation will become important because at larval stage, they are very tiny. Some of them are less than a millimeter. So they are at the mercy of very powerful currents. And one of the circulation maps that you see here is here for Lake Michigan. You see that this is generally cyclonic circulation pattern, and we'll be looking at how this circulation impacted the transport of larval mussels. I will be talking about two particular types. One is that is already here, advanced from the Straits of Mackinac. It's called Quagga mussel. And another one, potential invader, is Limnoperna. It's on the bottom here. It's a native of Southeast Asia. It's a warm, water-loving mussel, but with the climate change, there's a fairly good chance that it may show up here. So we want to know if it comes, where will it go? And I also want to mention that initial invasions are frequently due to shipping, ballasts due to ballast water exchange or recreational boating. So I'll begin with the Limnoperna. So we predicted the spread of Limnoperna from major ports in Michigan. So basically from ports in the south, like Port of Chicago, to Port Inland way north. So we used the particle model, which it was developed here by my colleague Dave Schwab. The model is three-dimensional. So we release particles every day during the spawning period, basically from May to October, and we do this during the 6-year time. So, and like I said, for Limnoperna, it has a relatively long pelagic phase, so the drift time is 20 days, and we predict that it will settle here in Michigan at the depth no deeper than 50 meters. So that's why you see there's a 50-meter isobath here contour, so they don't go below, they can go, but they cannot live. We think that they cannot live beyond that depth. So you see that a pretty significant spread during that release time. For some ports, it's like Charlevoix up north. It's not huge, but for some are really big, like for Chicago. So because it's not here yet, we used the data on the observations of the Quagga mussel, which Tom Nalepa collected, and try to predict, using the same model, try to predict if we can reproduce the spread of Quagga. So here on the left panel, you see they're beginning to spread in 98 near the Straits of Mackinac, and then we kind of advance them based on where they go in the first year. So in 99, they cover a larger area. So my last slide shows the comparison between the observations, which are on the top panel in 2000, where they begin. You see the beginning of the spread in the northeast of Michigan, and they finally spread south, more or less cyclonically or counterclockwise around the lake. And then by 2005, They covered pretty much the whole lake except the deepest area. And the model prediction, which is at the bottom, shows that the model actually does a pretty fairly good job in that. So I think I have to stop here. But my point is that it's the lake circulation is pretty effective mechanism for spread of invasive species. Thank you.